Hvala Dušku i Danku što su se obratili skupu i što su nam rekli novosti iz Ratela i iz Ajkana i kakvi su planovi. Sad ćemo krenuti sa onim oficijalnim delom konferencije i prvi govornik će biti Ferenc Csorba iz Rpki. Ono što je interesantno to je da na internetu imamo dva ključna protokola, to su DNS i routing protokol, i oba su bila razvijena u vreme kada se nije mnogo razmišljalo o bezbednosti tih protokola, jer je bilo jako malo računara na internetu i to su sve bili poznati korisnici. I poslednjih godina su oba protokola pretrpala znatne izmene i bezbednostne dodatke, tako da će nam Ferenc reći nešto o Rpki-u i o security developmentu vezanim za rutiranje.
Good morning, dobro jutro. My name is Ferenc Csorba. I'm from the RIPE-NCC, and I will like to talk about Rpki. And as you can see, Rpki developments in the routing security. So, yes, I think it's easier, because then I can see my slides. So, first of all, who are we? You probably know, but if you don't know, we are the RIPE-NCC. I work for the RIPE-NCC, and we are one of the 5 regional internet registries. So we are the people the organization who hands out IP addresses, AS numbers in the European, Middle Eastern, Central Asian region. What we do is we ensure unique holdership of IP addresses and AS numbers. We register the holdership in the RIPE database, and also we enable operators to document the use of their address spaces also in the RIPE database. And the whole subject of routing security, we are very involved with that since the very beginning, and you can see that in 1994, the first document using common language to describe routing policies has been created. We co-developed the standards for the IRR. So if you hear IRR, Internet Routing Registry, so the RIPE database, perhaps you're more familiar with that, that's part of it. So we co-developed the standards for that and for Rpki, about which I want to talk now. We are one of the 5 Rpki trust anchors, so each of the regional internet registries, like the RIPE-NCC in Europe, is one of the trust anchors for Rpki. And until recently, our validator tool, so that was the tool that you can use to check the validness, the validity of BGP announcements. We were the only one who had such a tool until recently. So the idea with Rpki, why do we have Rpki? It's a very simple question we want the answer to. Is that AS number authorized to announce that address space? That is the question. So the question is very simple. Here you have the whole thing sort of on a diagram. You can see the 2 AS numbers, and they are getting announcements perhaps from each other or from wherever, and they want to know, should I put this into my routing table or should I not? Can I trust this? So that's the question. So, of course, if you say, can I trust, you don't always have to think of something malicious. Actually, most of the time, it's not about people being malicious or people want to... people want to do anything negative. It's actually accidents. So very often, most often, fat fingers, all kind of accidents, like, you know, the accident with Pakistan Telecom and YouTube. So those were mainly accidents. But of course, not only accidents. In this year, last year, we also had a famous case when it was maliciousness, so hijacking. Here you just see some statistics. How often does that happen? So you can see in 2018 we had 12,000 incidents. 4% of all the ASs were involved with that. And you can see 3,000, so that means 3,000 ASs were victim of it, and 1,000 ASs actually caused such incidents. So the solution, of course, what you are probably familiar with is the Internet Routing Registry, the RIPE database. If you have perhaps your ISP updates their filters automatically from what's in the RIPE database, what's in the Internet Routing Registry. So the Internet Routing Registry is a distributed set of databases. One of them is the RIPE database. For example, another example should be, can be RADB's database, and so on, at least about 30 of them. So what the Internet Routing Registry, the RIPE database, helps you with is the verification of the holdership over resources. So you can see the RIPE database is mainly for our region, the European and the regions around it. And because we hand out these resources, the RIPE NCC hands out IP addresses and AS numbers, we do know who holds which IP address and which AS number. So that's quite clear. RADB, of course, they don't hand out any resources, so they have to verify it. Here you can see that they allow paying customers to create objects. And many of the databases in the Internet Routing Registry actually don't verify it. So here you can see the accuracy of the RIPE database for different regions in the world. And of course, the greener it is, the more accurate it is, from 0 to 100%. It's the percentage of valid announcements over covered announcements. Yeah? So how many of the root objects, you could say, is actually valid and actually reflects the real life situation. So that's for the RIPE database, and you can see for the European region it's quite good. For other regions it's not very good, but that is not also our job there for those regions. So that's actually okay. And here you can see the accuracy of the RADB database and routing registry. You can see it's quite different which regions are more accurate. Anyway, so as you can see, the solution with the Internet Routing Registry for routing security is not really 100%, and that's where RPKI comes into the picture. That's where RPKI comes into the picture. So what is RPKI? You can see it's resource. Resource means IP address in this case. Public key infrastructure. It ties the IP addresses, it ties them and the AS numbers to public keys, and it follows the hierarchy of the registry. The registry, RIPE NCC, for example, hands out address ranges to members, LIRs. Yeah? This keeps disappearing. What happens is there is a chain of trust in RPKI. We are going to see that in a moment. And it follows this hierarchy. And the whole point of RPKI is really just one thing, so that you can create a certificate for your address space. And then from that certificate, you can create something called ROA. If you're familiar with the RIPE database, then the ROA is a bit like a root object. It does more or less the same kind of thing, very broadly, as a concept. So what the ROA does, it's authorized, and that's the important thing. So there's PKI chain of trust from the trust anchor RIPE NCC all the way to the point where you create a ROA, and in the ROA you say, this AS number is authorized to announce this address space of mine. Yeah? So that's a ROA. And it is signed, so cryptographically signed, so that's the point of RPKI. So how long has it been around? You can see it's been around already for 11 years, and all the regional, 5 regional internet registries are operating it. It's community-driven standardization, IETF, because the routing registry, because the RIPE database was not sufficient, and that's why we came up with the RPKI. And so it's add crypto security to IP addresses, AS numbers. And this is the concept. So the most important part of this diagram is the dotted line in the middle, okay? To understand the concept, what happens is you get a certificate if you want, you don't have to, from the RIPE NCC. From that certificate with your keys, what you can do is you can create a ROA saying which of your prefixes can be announced by which AS number. Yeah? So that is the ROA you create on the left-hand side. And that's the end of the story for you. Now, someone else, and you could call that the validating party, wants to know if they can trust your announcement. And so they are going to make use of this, what you created. So what they do is they validate, they download software which is called the Validator. And with the Validator, what they do is they can validate all these ROAs everyone has created, like for all the different, on all the different continents, for all the different, so all the ROAs, and from that they prepare validated cache. So in their cache, in the Validator, they're only going to have the ROAs that are valid. And this is directly then linked to your router, because most routers actually have this already integrated, and then you can make routing decisions based on that. So you get the information, this prefix announced by that AS, yes, that's valid, based on this RPKI chain of trust, so you know you can trust it. And then it's completely up to you, the decision you make. Sometimes people misunderstand it and they think someone else is pushing decisions on them. No, you have this information and you do what you want with it. Either you ignore it, or if you say it's validated, then you give more preference to it, or if it's invalid, you give less preference, or you don't accept it. It's completely up to you what you do with it. It's just information there. So no one is actually pushing you to do anything. You have an extra information to be more secure about it, and you can do whatever you want with it. So that's the concept. And here you can see that one more time again. At the top, that's the RIPE NCC. So we are the trust anchor. We have all the resources, and we are the certificate authority. And if you want, you can get your certificate. That's in blue. And from your certificate for all your address space, you can create ROA any way you want it. You can choose whichever of your prefixes, and you can put in any AS number saying, I allow that AS number to announce my prefix, and I sign it. And then all that information is on the RIPE NCC's platform, so it's very simple. I'll talk about that perhaps later. You don't really have to do anything with keys. It's just like 2 or 3 clicks of a mouse, really. Yeah? Okay, so this is the structure. And what is a ROA? So if you create a ROA, it has 3 pieces of information. It says this range of addresses, that's the address space, the prefix. The originating AS is originated from that AS, and then the extra information is the maximum length. So let's say if you have a /21, you can specify maximum length is just default, then only announcements that are size of a /21 are valid, a /22 is not valid. But if you make the maximum length longer, you can say the maximum length is /24, then anything between the sizes of /21, which is your address range and /24 would be valid. So you have to choose that as well. And you can create one or many ROAs. So someone just asked me, what happens if I have an assignment? You can create a separate ROA with separate AS number for your assignment of your customer. So it's whatever you can do with routing, you can do with RPKI ROAs. Yeah, so you can completely mirror the situation. So as I said, this is the important part, the dotted line. Until now, you set up a certificate, you create the certificate, you create a ROA, and now someone else is going to use it to validate announcements. And that is how it works. You have the 5 trust anchors. Those are the 5 regional internet registries. You need a validator, so you could even, for example, just download it on your laptop, but it's obviously you're going to have a machine in your network, a validator, and the validator will get all the information, all the certificates and the ROAs, and then create a validated cache. So it will check using this RPKI chain of trust, it will check the validity of all the ROAs, and only the valid ROAs it will put in the cache, and after that, that is then communicated, I don't know, in whatever periods with the router, and then so the router doesn't have to do the validation, it doesn't slow it down, and then the router can compare it with the announcement to see if they are valid or not. So here you can see on the left-hand side, you have you as a user, you have the validated cache that you created with your validator, and then there you have your router, and there you have the BGP announcements, and then you can compare the two and then make whatever decision. But as I said, the decision is yours. You then can configure your router and say, if valid, then do this, or don't do this, or whatever you want to do, yeah? So this is now the full system. At the top, you have the ROAs in the repository, which is on the RipNCC's platform. Then you, the validating party, has the validator software. In the validator will create the validated cache, only those ROAs that are valid, that says which prefix is announced by which AS and which are valid. It has checked it. And after that, you can see the protocol is RPKI RTR. That's the protocol between the validator and your router. And most platforms, most routers actually have this already built in, so they understand this. And then the routers can make whichever decision based on that. Okay, a little bit of statistics. So you can see here for the 5 regions that, of course, RipNCC has the most certificates. So a certificate, you only have one certificate, and in your certificate you have all your different prefixes together, IPv4, IPv6. And then you create ROA for each prefix separately, yeah? So these are the number of certificates, and we have just passed actually 10,000 a few days ago. So you have, in total, if you add this all up, you can see there are 30,000 certificates. And you can see the coverage. So you can see in which regions in the world, how many, what percentage of the announcements actually have ROAs, has actually created ROAs for which announcements. And you can see, of course, for example, in Europe, it's quite high. It's between 0 and 100%. And then here you have the accuracy. So that means from the ROAs that are created, what percentage actually completely reflects what is actually being announced in real life. That's the accuracy. And you can see that again between 0 and 100%. And here you have some statistics for the region. So you can see that 66% of the addresses actually in Serbia already have ROAs. So based on RPKI, 66% have created ROAs for their address ranges in the Republic of Serbia. And then you can see all the other countries there, and you can see the accuracies. From these ROAS that they created, what percentage is accurate. And you can see the accuracy is really high. So there aren't a lot of mistakes, let's say, let's put it that way, or malicious, yeah. But that, hopefully, that you can't create. Okay. Right. So what should you do? Create your ROAS in the LIR portal. Perhaps what I should tell you just very briefly, what does it mean if you want to do this? This is very simple. If you're an LIR, you go into your LIR portal, and you can just click a button, I want a certificate. So it's your choice. If you want a certificate, you get a certificate, and then you can create ROAS. The interface is very easy, because the only thing you will see all your announcements. We have that from root collectors, so we collect it from the internet. You see your actual announcements, not what's in the database, but the real life. And based on that, you can, for each of your announcements, you can create a ROA. Yeah? And it's just a click of a mouse, so you don't have to worry about you have logged in any kind of authentication keys. That's done automatically. And so you create your ROAS in the LIR portal. The important thing is to pay the main problem can be the maximum length. So if you create a ROA for your announcement and you just say default maximum length, and your announcement, your prefix is a /21, then if you want to announce a /22, that will be invalid. If you know you want to do it, then you have to change the maximum length when you create the ROA or later, and change it from default to /22 or /23 or /24. Also, as I said, if part of your allocation belongs to your customer and they are announcing it from a different AS, then you can create separate ROAS for the rest of your allocation from your AS, and you can create a separate ROA for your customer with a different AS. Yeah? So you can do whatever you need to do. So create your ROAS. Make sure you get the maximum length attribute correctly. That's the first part. So now you have done so that others can use RPKI to validate your announcements. Your job is finished here. I mean, okay, you check it occasionally if it's up to date and all that. After that, you can also use RPKI to check the validity of what other people announce. And that you start by downloading the validator. You can also check the validator status. And if, for example, your grandfather is announcing a prefix and it's not valid, but you like your grandfather, you can update it manually. So you can make exceptions to it. So you have that freedom as well to add and remove ROAS from the validated cache. And after that, set up monitoring, and that's it. Now, the question is, what happens if you say, okay, I do RPKI, and I did it, and then I also do the validation, and then so I integrate it in my routing. So basically what I do is my router and the validator, they are going to check if an announced prefix is valid. And you say, I'm going to reject anything that's invalid. You're not going to reject anything that's unknown. Unknown just means that they didn't do RPKI, they didn't create ROAS. So that's not a problem. But if you see from RPKI that there's a ROA that says this prefix can be announced by them and someone else is announcing it, and what happens if your router now, based on this, rejects the prefix? And this is what we found out, what people's experience is, what you see on that slide, what happens. So to summarize it, it's not a big problem. So, for example, someone created a bad ROA by mistake, and now you reject it because they made a mistake. How negatively will it impact you because you reject actually something that they wanted valid? So basically, you see mostly nothing. That's what AT&T said. 5 customer calls in 6 months to give a feeling, all resolved quickly. Dutch ISP. Customers appreciate that you take security really seriously, so you use RPKI. There are many invalid, but usually it impacts very little traffic, because usually the major players will know what they are doing. So that's the feedback on that. So that's it, really. The question is, do you want to use it? Do you find this is useful? That's up to you, but we suggest you do. Questions? Yes? Is the validator open source? I don't think it is. I'd have to check that. Yeah.
Security practice.
I don't know. I have to check that. Yeah. No, it's not. What basically about security, I mean, the easiest way to say, if you are worried about security, it's more like an indication. I can't go into the depth because it's not me who developed it. But what I can say, major first-tier ISPs are using it, and they haven't had any incidents until now. Okay, well.
Ok, thank you, Ferenc. Naš sljedeći govornik je gospodin Gyorgy Acs iz Ciska i on će nam reći nešto o hvatanju cyber kriminalaca, tracking the cyber criminals with umbrella system.
Yeah, unfortunately my Serbian is also very weak, so sorry. Dobro jutro, that's all. And first, I would like to speak in English, if you don't mind. So let me introduce myself. I work for Cisco, so I'd like to introduce a very, very important problem to you. You already know very well regarding DNS. So I don't want to go into the technical details now, but what we are doing now is just connecting dots. So do you have any guess what the picture shows? Yeah, so finally a bird, yeah. But in the first view, probably you cannot see immediately. So that's, we need some like artificial intelligence or something a little bit deeper investigation. So regarding my talk, I'd like to introduce this umbrella, very, very short. Regarding the services, it is free of charge. You can use it. You can learn a lot of things from this one. Plus, I'd like to introduce very, very quickly regarding the architecture and regarding the algorithm behind this service. So basically, it provides secure DNS transactions and resolutions. And finally, I'd like to introduce a few examples where we could use this kind of algorithm. So very, very quickly. So regarding the umbrella is it's a free of charge service with this like home users and like parental control, so it's still available as an open DNS. So maybe you heard about Cisco acquired open DNS, and still we are using quite heavily and investing a lot with this open DNS. The name is Umbrella. So based in the Umbrella, we can provide these services. By the way, what do you think about this? The volume of this DNS request. How many times we have like a DNS resolution or DNS request per day? I would say an average user. Do you have any guess? Just think it over how many times you are clicking, open a browser or something. A millions or a billion? Thousands, yeah, it's not a bad guess. Like actually the average user takes like 2,000. So this is not really a bad example. And this is the problem with this DNS resolution. So if you just visit one single site, like CNN.com, we'll open a lot of different portals. Just opening one single portal, you have like 26 different domains, resoluting a lot of other portals and websites as well. So this is quite difficult to even investigate one single site with this one. The problem here with this with the DNS, typical organization don't monitor these DNS requests. This is very huge problem, because this looks like a golden mine. So it is very important for security point of view to investigate, even control it. So therefore, we are doing this one with the umbrella. This is the first layer of security, because just using the DNS protection and DNS resolution and blocking this DNS, it helps a lot in security point of view. So, yeah, let me introduce the umbrella very quickly. So here we have like a worldwide service covering, like we have different, like 30 different towers covering all of the worldwide services with very easy service introduction. So this is just like a global service covering all of these things. And let me show you like why it is important to use it, because if nothing else, if you use just fast DNS resolution, that's more than enough. I showed a picture. If you see, umbrella is the second one, even worldwide point of view. If you think about the Europe, this is also second one. So this is not a big deal, even if you can use it just for the fast DNS server, that is more than enough. So regarding the first one, this is Cloudflare. This doesn't provide any security. So that's the problem with this, the number one, because there is no like security enforcement applied here. They are just a quick resolution. And yeah, this is just for the European things, and this is quite easy to apply this security countermeasure. So this is just the first step. You need to just change the DNS server configuration on the router, pointing to the server nodes. Here we have IPv4, IPv6 addresses. That's all. Everything else managed through the cloud. So here we have even cloud services through this OpenDNS. You can do this with the parental control and everything with the basic security point of view. So with the visibility, enforcement-wide deployment, you can do a lot of things. Basically, what we have here is two services. One, the name is Umbrella. That's the enforcement point. And there is another one which is called Investigate. Investigate is nothing else, just an open interface to the database. So it's very important. This is a live service. We need to investigate every single DNS request on the fly. So this is not like a static database we could share with you. Therefore, we have like an open interface. So Investigate has like two types of services, like graphical user interface. I will introduce very quickly. And there is an API interface as well. So for example, if you want to like block something through this database, you can do a lot of things with these services. So let's continue with the big data. So this is the number of the DNS requests per day we are serving. So just regarding the volume, it is close to 200 billion requests per day for the supported customer set. Covering home users, parental users, home user, and enterprise users as well. It represents like 2 or 3% of the worldwide DNS traffic. So it's relatively huge volume. So basically, this is a perfect input just for the database, the machine learning data algorithm. So therefore, we have a huge volume. Just a few numbers. There was like 175 billion per request, altogether like 90 million active users very closely, and now increasing quite heavily. So that was the OpenDNS numbers. After the acquisition of Cisco, increased a lot. So nowadays it's more than 200 billion. So this is how we see the internet request and the internet DNS names and domains. So this is not just the domain names, but we see the file hashes as well. So here we have a sandbox connection. So if the sandbox connection reporting like a malicious domain, we can see it and we can report and we can monitor these ones. Plus the DGAs. DGA means domain generation algorithm results. So this is the new technique of cyber criminals, how they can frequently changing the domains. Quite rapidly changing the domain resolutions and registering totally new domains. And you can even predict if you are quite clever. Okay, so this is what the DNS umbrella can do is just the recursive DNS services. So if there is a home users or there is a PC, you need just pointing to the DNS request to these services. And of course, it will provide the DNS resolution towards to the other services. Of course, providing additional like security countermeasure, security services and controls. So for example, blocking DNS hijacking, fast flux domains. For example, this is just quite rapidly changing the IP addresses. This is also more than suspicious. So this is typically not a valid service. If you are changing very, very rapidly the IP addresses behind a given domain, this is more than enough. A lot of different algorithms I will cover a little bit later right now. So it looks like a statistical models. Here we have a lot of different PhDs and engineers working 24 hours, defining these malicious activities based on these DNS requests. So a few statistical models I'd like to introduce, but not everything. I'd like to introduce the most important ones. Yeah, so this is how we see, for example, one given domain, like blackhat.com. So here we see the connection pointing to the other domains as well. So for example, if the user is visiting other domains in the same time, or connection to the other IP addresses, or even ASN numbers, autonomous numbers, and you can see the connection. Yeah. Yeah. False positive is it's very, very valid question. So every customer can report the false positive on the website, and or engineers and PhD scientists can work on the false positives. Of course, there are false positive, because if you think about that, based on the algorithm, they can of course provide false positive, and of course immediately you can report. Exactly. Plus, there is, I will cover a little bit later if the slide helps me. There is a totally new category, which is called newly seen domain. Newly seen domain, as you know, the term explains, it's a new category. So typically, if you think about the very well-known services like Google, Facebook, other services, they don't open every single day different domains, right? So this is typically not every day you are visiting a totally new site. So if typically what they are doing, the cyber criminals, they need to build an infrastructure. So therefore they are opening quite heavily totally new domains. So one of the very, very good technique is just put everything into the newly seen domain category. If it's totally new, why? Because in this case, you can block it. This is like a temporary container just for this totally new domains. And that was a very, very good example. Do you remember WannaCry? So the WannaCry had like a kill switch. So the kill switch was that a domain was registered as blocking all of the activities. As somebody did it, finally registered this kill switch and blocked everything. With the WannaCry, and that was a perfect an example how we can effectively blocking this kind of new malwares and new cyber criminals activities. Not really. It is totally machine-based services. I wouldn't say machine learning, because if we haven't seen a totally new domain, we put into the a temporary category like newly seen domain. And after 24 hours, I tested with my customer the totally new Hungarian domains. And in 24 hours, we recategorized into the right category. If it is like a shopping, if there is a I don't know, advertisement site, it will be totally automatically categorized. But until it's a perfect category matched, we have a full protection. One of the algorithm is just a co-occurrence model. Co-occurrence is just checking what is the connection between the domains you are visiting. So for example, if X is a malicious domain, probably if you are visiting like C and D among relatively short time frame, there is a higher chance that these domains are connected to this malware campaign. So therefore, this could be more than malicious, these things. Okay, what do you think about these applications? Have you heard about like Shazam, Pandora, and these kind of things? What they are doing? Any guess? They are dealing with voices or songs and these different things. So this is typically, it's a good recognition for us as well. Believe or not, but typically if you see the the pattern of this DNS request, it helps a lot in the science as well. It's funny. Maybe I can draw. Okay, so the name is model is like spike rank model. Do you see even domain generation algorithm shows this kind of pattern? If you see the exploit kits, you see these spikes, and phishing is this one. So even if you see nothing, just how this DNS request patterns look like, that's more than enough for this recognition as well. Geolocation information helps a lot. For example, if there is a server in Serbia and the victims came from US, is more than suspicious, right? It cannot be a legitimate service. Of course, nowadays it's nobody knows where the server is. That's I fully understood. But this is not a typical situation. For example, if there is a server in Ukraine, that's more than enough. Okay, that one is quite nice. Live Dga Prediction. So if you have a lot of information regarding the domains, like visited domains, we can even predict what is the next one. The name is DGA, like domain generation algorithm. If you have enough samples, enough examples with these DGAs, you can calculate, and you can calculate the next one. So this is how it works. A.com and B.com, you see a lot of things, and if you see a seed function, how this DGA works, you can predict the next one, and even block before registering the new domain. That is very, very important, because if you are absolutely sure that this should come from the DGA algorithm output, you can block immediately before the registration. Yeah, like B.com, and if you see everything, even you can predict the other DGA outputs, like this one. And we do it. If you have a malware campaign, and if we can predict these totally new domains, we can actually block it on the fly. Okay. So this is I already mentioned this newly seen category. So if it is totally new domain, we can put into the new domain, a newly seen domain category until we can have more information. So the gentleman had this question. So using this newly seen domain, you can block a totally new domains in the world until we have a protection and full service with this category. So regarding the new categories, I'd like to introduce two major ones. One is the malvertising. So probably you heard about how cyber criminals work. Typically, they are using exploit kits. If you heard about, there are some very, very famous ones, for example, Rig exploit kit and Angler exploit kit, so how they operate, how they infect victims. So typically, they have this one, infected sites or advertisement networks, and they have a totally, an industry, like a company, how they operate and how they build an infrastructure using this exploit kit infection. And here, this is the chain of the advertisement things, and every single steps could be infected with this malvertising services. So, malvertising is just sharing malware codes to the victims. So therefore, this it could be quite interesting and quite dangerous. This is just one example. So if you, JEPs can, for example, visited this site, immediately can redirect to another site, just showing that, for example, there is a problem with your PC. So you need to update your Acrobat Reader or Java or anything what sitting on your network. Even they have a tailored setup as well. For example, if you have an Apple device, they can recognize, okay, you are an Apple, so therefore you need Apple antivirus. quite nice story. So this is just one example, but this, yeah, you see, so in this case, you see that, for example, Flash update is needed. So it's a typical case. If you're browsing the web, you see every single day, almost. So this is just one example, but if you see these advertisement campaigns, yeah, here you see a few examples. They work like this one quite heavily. This is another example. This is the tech support scam. So pointing or redirecting to the tech support that, okay, your PC is damaged, infected, please do nothing, or tech support will help you. So this is the typical situation. This is another example of fake Flash and Java updates. And if you see now, content free and safe for update. So this is the click, I mean, this is the domain they are expecting the user to click. And they are clicking. You know, that's nothing a big deal. You know, if there is a human, you know, can read it, okay, safe and free, why not? That's that human thing. So what they are doing. And this is just an example how this advertisement campaign tools look like. So here you can do a lot of things. You can configure even the country code and region code, and you know how would like to redirect using the iframe. What is the malware you would like to inspect, infect using this tool? So this looks like a, you know, you don't need an educated user to create this kind of campaign against the victims. So it can be very, very tailored as one, but if you want to infect several millions of people, why not? You can do it. Okay, so this is just an example from the Investigate story. So this is how this domain look like. So for example, I just put content free and safe .star. Star means like regex, you know. So here you can have a list up to like 30 days, as I remember. So here you see all of the domains. So they are changing the domains. Because if there is a firewall blocking one of them, okay, no problem. Still, we have a lot of other ones. So therefore, this it looks like an industry. So therefore, the machine learning is needed here to like checking all of these things and these domains to block in one single shot. Okay, so if we see these words, you can classify which is somehow connected together. So for example, if you think about the English words and terms like content, free, and apple, you can even predict that pineapple could be the next one. So even this kind of things could be predicted by the machine learnings. So yeah, if we can use like synonym typos and these kind of things, therefore this is the place for the machine learning. So for example, there is a domain, we calculate the trigram. Trigram means the three letters together, like cont, ont, nte, ten, and so on. And this one could be calculated the hash value, and based on the hash value, we can have like locality sensitive hashing. This is just a calculation what other domains could have here based on the campaign. So this is just an example for these ones. So even from this given domain, we can predict the other ones. So for example, content 4. So do you see the 4 is moved from here to there, but even is the same campaign. So even you can block it based on this, even the first domain, you know, if you found this one. Okay, so for example, this could be the result of the lexical clustering. So if you see this one, it could be like a fake update campaign, but the other one could be the tech support scam. Just based on the different domains, even you can predict what is what could be even the next one, or you know that what is the category. Of course, here you can cluster the legitimate advertisement campaign as well. So this is not like a magic things, but basically the machine learning can do it. Okay, have you heard about the Puni code? No, nobody. That's it's a shame, unfortunately. Why? Because that's if you think about the serial characters. So sometimes you need, or somebody from your country, they are using serial characters even for the domain. So the Puni code is just like this is the picture from the Puni, which means like small things. So this is just a representation of the Unicode with the limited ASCII character subset. So even here you can have like Cyrillic characters or Greek or something. Even Turkey has special characters. And if you would like to use in the domain names, of course, DNS doesn't provide this kind of support. So there is like a coding system, and this name is Punicode. So yeah, for example, this is like a thank you, Efaritus. This is like you know, the Greek word for the thank you, and this is like how the users want to see with the domains. So for example, Alibaba, this is the Chinese you know, web shop site, and I mean they prefer to use their characters in their countries. This is the Japanese Ministry of Internal Affairs. You see, this is really a special characters, not talking about Yandex, which is the Russian Google, you know, and this case, probably this is the case in Serbia, so probably you would like to use your Cyrillic characters as well, right? So in the domain. So this is like a Punicode translator as well. So if the user typed here into the domain, it will be translated to this one, to the DNS server, because this is the you know, the DNS server can resolve and can use it. If you notice, this is starting with the X and minus minus. But you know, if just blocking with all of the X and minus minus doesn't help. That, you know, it's not a full service. Somehow you need to like translate to the visible format. So like a human things. So that's quite nice. Just a few examples. Would you click to this one, SingaporeAir.com? Somebody? Do you have any guess? It's a legitimate site, so don't worry. Why not? What do you think about this one? Not really. Okay. So just a few examples. If you haven't noticed, there is one, but there is another one. For example, that one. Maybe in the first view, you haven't noticed that. What's the problem with this one? Just, yeah, another example. Just imagine you are using your phone. And your phone, you got an email. Oh, what's this? Oh, yeah, I'm flying tomorrow. Why not Singapore Airline? With Singapore Airline, why not clicking there? That's the trick, you know? So that's the problem. Just a few examples for this one. Singapore Airline, yeah, you see? There is a dot behind the E. And this one, it's quite tricky. Do you have any guess? R, yeah, the last letter, yeah. The R is not like a native R, like we have in this setup. And you see it? This is how the cyber criminals work. They have, I mean, dozens of different domains registered just for the Singapore Airline. Amazing. And this is really a nice trick. My colleague tested this one. He registered the umbrella, and this works very nicely. Do you have any guess what is the legitimate one? And you see, for example, a few ones. This is just an example, but quite very good ones. If we can, you know, step a little bit closer, Milka, Rolex, another Rolex, Ryanair. So it's a very, you know, high profile domains are actually just played with this. So in this case, using the X and minus minus, you see everywhere is there. There is like a table, like a mapping table. If you want to use R, not like a native R, but you would like to replace the legitimate R, what you can use it. So it looks like a, you know, on the internet you can find these sites, you know, showing what is. If you don't want to use the Z, you know what you can use instead of the Z. Okay. Actually, my colleague tested as well with this iMessage as well. Without any problem, you see this is Rolex. So even the iMessage translated or I showed the legitimate one. So in this case, you know, the trick worked very well. And if the other, yeah, you see Office 365. If you are, you know, I will share the presentation. You see the I has a little bit longer, you know, dot. I mean, not like a dot, but a long accent. That's the trick. So in this case, you can register this not Office 365 domain, but, you know, a little bit different one. And of course, this is Chrome, showed this one. Facebook, Firefox showed the right one. Only the Facebook could block it because that contained the X and minus things. So as you see, it was blocked successfully, and even the Snapchat is also showing that as a legitimate site. So even the Gmail showing the right, the Singapore Airlines, so didn't block that malicious content. You see that it's quite very huge trick, and nowadays it's getting worse day by day. Even Twitter showing also the bad domain. Okay, so this is the Punicode. If you want to test, just please visit this umbrella site and you can test yourself. I tested myself. I cannot demonstrate now, but in the break I can show you. It's showing, for example, the Safari showing as a legitimate site, like umbrella.com. So quite funny. Okay. So this is just a few examples. Like a blockchain company in Turkey, LATAM, Google Analytics, if the projector helps here. So just a few examples on this one, Fox News, and these are also quite funny ones. I don't want to read all of the things, but you see PayPal, Red Bull, or Twitter. All of them is just a victim of these Punicode victims or attacks. So this is just Punicode, and how we can manage, how can we cope with this Punicode attacks? So one of the things we can do with the newly seen domain. So if it is totally new, you see, this is the domain was registered, X and minus pay PL something. So this is currently put into the newly seen category. So it's finally blocked if you want to do so. If not, of course, this is totally your setup or your installation. If you want to enable or see this kind of new domains, why not? But this is a quite huge risk. Malvertising checking is there, and there is another one, which is the Levenstein distance filter. I guess everybody heard about, right? No, probably nobody, yeah? So this Levenstein is just nothing else but like a string comparison algorithm. How can you compare two strings together in order to calculate the distance between these things? So it is nothing else, just like kitten to sitting. How many characters you need to replace in order to get to the final sitting? So I don't want to read it. So starting from the first letter, like K, so you need to replace the K to S. Okay, that one. The next one, you need to replace this one, and finally add G. So the value is free. So calculating this distance it helps a lot. If the distance it's relatively short, quite similar to the legitimate site. The next one, what we want to do is just checking the content of the site. So here, quite funny. I hope that finally you will fix it, because that will be a fun for the whole day. So regarding the Levenstein distance with the PayPal is 2. So it's relatively close. So therefore, this kind of natural language processing helps a lot. And the other one is just the site investigation. If the site looks like an original site, it's more than suspicious, right? Because this looks like a fake site, for example, for the PayPal. So therefore, this kind of site can be blocked without any notice. So if the site similarity is very high, in our case, it was like more than 82%. So it's more than enough. So in this case, we can block it immediately. And this is good for the additional database, pivoting, the other things. If this is not the case, of course, human is needed. So somebody needs to see it, needs to check it. Is it a legitimate site or not? So this is like a procedure how to cope this Punicode example, Punicode things. That's funny. It was very quick.
So, do you cooperate with other DNS providers? Do you share your findings?
Yes.
Do you, how to say, coordinate your activities with Cloudflare, with Quad9, with Google, with other resolvers?
Yes, we do. And actually, not just providing, I mean, sharing information, but the API is also free. I mean, available. I wouldn't say free, but because it's a paid service, depending on how many requests you would like to apply. But yeah, at least the database is available.
Yeah, the Pony code was interesting. The story, yeah. The concept is interesting. So why doing the same job 3 times? If already you done it, why not share with, with others?
Yeah, exactly. So unfortunately, I have other examples, but time is over also, and the projector didn't help too much. So thank you very much for your time, and good luck for the next presentations.
Thank you. I have to apologize to you and to audience as well. There is a problem with lines between projector and computer, and it causes more problems. So I hope we'll fix that during the coffee break. Now we have planned a panel discussion, but I would ask George, are you going to stay? You have asked to be put at the beginning of the conference. Are you able to stay until the end of second block? Because I believe that your input would be really essential after we hear other people. And I would just ask a couple of questions for Ferenc, and if somebody from audience has questions as well, I would appreciate. Okay, thank you. RPKI is a very interesting topic, and I was surprised that when I saw that 66% of routes in Serbia are RPKI signed. But can you tell us why would somebody do that? What is the impact if not doing RPKI signature and protection of announcements?
Well, I would start with, if you don't do it right now, I would say the impact is, I would say, practically none, if I can put it that way. But as you can see that there is quite a large uptake, so as you said, 66%. And I had a slide about that. So basically there are 2 things. One thing is what happens if you don't do RPKI. If you don't do RPKI, then those people who use RPKI, so who are using a validator, they are going to see your prefixes as unknown. And usually unknown, people understand that just means that it's not being, your prefixes are not using RPKI, so it doesn't really have any negative impact because people are aware of that, so they are going to, it really boils down to each user because they are completely free to do with the result of the validation what they want. So the people are not restricted in that. So it's a bit statistical to predict what will happen. It's up to the user. They get the information, the prefix is valid, and then they can configure their router in whatever way to deal with the result of the validation. So it compares the BGP announcement to the validated cache, and the result can be unknown, valid, invalid. So I think the main point is if you use it and you misconfigure it, but that usually doesn't happen that much. As you saw that the accuracy is very high, so you can see it's not something that people normally misconfigure. But if you use it and someone else is announcing your prefix, then most people who use the validator would configure not to accept those invalids. So that would be the only drawback. Not using it would not be at the moment a big drawback.
Okay, thank you. But my question, let me rephrase that, was what is security danger if somebody doesn't use RPKI, or what we can prevent by using RPKI?
So, as I said, the reason. So, what did we have until now instead of RPKI or before RPKI? So we had, as if you are aware of that, root objects in the database. So ISPs can use that to automate the creation of their filters based on those root objects. So, but of course the problem is not really the RIPE database, but the whole routing registry is 30 different databases, and the RIPE database, the information we have is first-hand because we hand out the address ranges, so we know first-hand which address range belongs to whom. But in the other routing registries, for example, there was an example you saw there, that's not always the case. So we can't guarantee for the other routing registries that the information would be 100% correct.
Okay. Thank you for that. I'll try to get my picture and to explain. You can jump in and
yes.
Elaborate that. You know, we are trying to prevent BGP hijacking, yes. And that's very important. And some people are saying, I don't care where my routing table and pairings are going. I only care that my services are up and running and secure. But what can happen if IP range is hijacked? It is that somebody else can bring up services, same as mine, advertise that, and do, in our case, DNS
yes.
DNS service for TLD, or some services for World Wide Web, and after that we are redirected and also have another problems.
Do you want me to jump in now? So yes. So if you are using RPKI, that means you created your ROAS correctly, and those who are using your services are using RPKI, so they are using the validator. Then what would happen is if it is hijacked, then those announcements of the hijacker from their AS number would, in the validator, you would have your ROA, the valid IP address AS number combination. And if they announce that prefix from another AS number, then the result of the validation would be invalid. And the idea is, if now it is used broadly, then if you get an invalid announcement, then you reject that. You don't accept it. So that would, in this case, this scenario, if you are using RPKI and your clients are using RPKI, that would solve that problem.
So that's important on both sides.
Yes, it is two parts. That's why I said the most important part in my presentation was the dotted line. Oh, sorry. The most important part in my presentation, remember the dotted line. So you set it up and someone has to use it. If you set it up and someone else is using it, you set it up and your client is using it, and the client configures their routers that any announcement that gets the validation result invalid is rejected, then such hijacks would be rejected. So these announcements of the hijackers would be rejected because in the validated cache, you have the validated ROA that you created.
So there is interest on both sides.
Yes.
Service providers and also providers who provide services to end users to protect.
Yes, it only works together. It only actually has a meaning when both sides use it.
Okay, thank you.
Hello, I have a question, Zoran Perovic. For us working with BGP for 20 plus years, we remember BCP 38, we remember Manners, which is actually quite up to date. What is the future of Rpki? Because all three of those, how to say, initiatives are actually protecting the others from you.
Yes.
Is there a way to enforce cyber hygiene, as we may call it, in order not to react on the incident, but to act proactively and protect for the good of the internet?
Yes. The problem, I think, if I understand your question correctly, is because if someone asks that question, but someone else says, is the RIPE-NCC now like a big brother forcing us to do our routing in a certain way? Of course, we have to answer that as well. So we are not forcing anyone. And so those are actually two opposing requirements in a way. So what we have chosen for is you get, so now I'm talking as a provider, you get your certificate, you create your ROAS correctly, and your part is done, and then it will only work, as I said, if your clients are also going to use it. And that's why we are really actively promoting it. And as you can see, probably quite a few of you were surprised that you have already 66% in Serbia, which is good, because if we have a very high percent, then this automatically works because the provider has it and the users have it, or let's say the user's ISP has it, and then it works, and then you can prevent such hijackings. Yeah.
Are there other questions from audience? Okay, thank you, Ferenc.
Thank you.